Welcome back to DigiLab Academy. I'm Anna, and today we're diving into part 2 of our series Building an AI Assistant with Streamlit, LangChain and OpenAI. If you missed the first video, don't worry, you can catch up by clicking the link in the description below. Before we get started, make sure that you visit the DigiLab Academy website where you can find the full written tutorial as well as the finished project and the dataset that we will be using. In this video, we're going to continue our journey to simplify your data science tasks. We'll pick up from where we left off and I'll guide you through enhancing your AI assistant. Now let's talk about what is on the agenda for this video. In this part of our series, we're diving into the concept of prompts, prompt templates, chains, and tools in the LangChain framework. A prompt is a set of instructions or input provided by a user, guiding the model's response. It aids the model in comprehending context and generating coherent language-based output, such as answering questions or engaging in conversation. Prompt templates are predefined recipes for constructing prompts. These templates may include instructions, few-shot examples, and a specific context and questions suitable for a given task. LangChain provides robust tooling to create and work with these prompt templates, allowing for the seamless reuse of templates across different language models. Typically, language models expect the prompt to be either a string or a list of chat messages. Chains are a fundamental aspect of LangChain. They are logical connections between one or more LLM instances. Chains can vary in complexity, tailored to the requirements and the specific LLMs involved. We will be exploring two types of chains: simple sequential chains and sequential chains. The simple sequential chain comes into play when there is a single input and a single output between chains. On the other hand, the sequential chain is utilized when there are multiple inputs and outputs. Prompt templates provide the structure for constructing prompts, and chains use these prompts as part of a logical sequence of interactions with language models. They work together to facilitate a systematic and organized approach to leveraging language models for various tasks with the LangChain framework. A tool serves as a dedicated interface crafted to execute a particular task. It typically involves a function that takes a string as an input and produces a string as an output. In today's tutorial, we're going to explore two different tools: the Wikipedia API wrapper and the Python REPL. First, we will create a prompt template to store the specific business problem or users aim to address. This will allow us to streamline the process of converting a broad business challenge into a focused data science problem. Additionally, we will create another template to guide the user in selecting machine learning algorithms suitable for solving a given data science problem. This second prompt template expects information about the data problem and additional insights from the Wikipedia research. With our prompt templates in place, we will then create two chains. These chains will utilize an LLM to interact with the prompts and provide information. We will connect these two chains using a sequential chain, enabling us to input a business problem and in turn, receive a reframing of the problem in a data science framework and a curated list of algorithms suitable to solve the problem. Finally, our AI assistant gains the ability to generate and execute Python code. To achieve this, we'll introduce a Python agent, a key component that interacts with the Python REPL tool. Users will be able to select an algorithm of their choice and use it to solve the problem they have presented. We will continue using expanders to provide additional information and text inputs to gather user information. We will be introducing two new Streamlit elements: the text area input and the select box. By the end of this tutorial, you have a more powerful AI assistant ready to help you in your data science projects. If you have any questions or you need any clarification, don't hesitate to drop a comment in the comment section below. And without further ado, let's jump into the exciting content that awaits us in this video. Don't forget to like and subscribe for more data science adventures. Let's get started. Okay, so we're going to continue what we left in the last video. So first thing that we need to do is to import the required libraries that we need to continue building our assistant. So from the LangChain library, we want to import prompt template, then for the chains, LangChain, simple sequential chain, and sequential chain. For the Python agent, we need create Python agent and also agent type. For our tools, we need Python REPL tool and the Wikipedia API wrapper. So let's write down. We go to the start of the script and we start writing this up. So we're going to add a divider to separate the exploratory data analysis section from the data science section, and we're going to add a header with the text data science problem to introduce our new section. We will also include some text to provide information about the importance of reframing the business problem into a data science problem. But first, we need to add a conditional statement to check if the variable used in question data frame is not empty or not none. So if the user question data frame is evaluated as true, then the code within the indented block will be executed. So let's write that down just here. Right, so okay, so the introductory text is, now that we have a solid grasp of the data at hand and a clear understanding of the variable we intend to investigate, it's important that we reframe our business problem into a data science problem. So we're gonna run see what happens, and there we go. So we have the header and then our introductory text. Now that we have our introductory section, we are going to write our first prompt. To do this, what we're going to do is to create a new variable called prompt and set it equal to text input, include a label that says add your prompt here. Okay, let's rerun, see what happens, and we can see that this text input has appeared here. Nothing is going to happen if we enter this because we haven't connected it to anything. We haven't connected it to our LLM. So let's proceed to do that. What we need is a way to trigger our prompt to our LLM. So if there's a prompt, we'll create a new variable for our response and pass the prompt to the LLM. And in order to render this back to the screen, we will use st.write. So let's do that. So as you can see, we're using the LLM that we used in the previous video. Right, so what we're gonna do now is ask the LLM if it can convert a business problem, specific business problem, into a data science problem. So convert this business problem into a data science problem. And the business problem is, I want to know what the volume of the Twitter stock market is going to be in January the 1st, 2025. Right, so I'm gonna click enter, see what happens. Great, so data science problem, predict the volume of the Twitter stock market on January 1st, 2025. So currently we need to write the entire prompt, but ideally what we want is our application to determine what should be generated based on a business problem that the user inputs. And this is where prompt templates come in. So we want to create a prompt template that takes in our business problem and it generates a prompt asking to convert the business problem into a data science problem. So to create our prompt template, what we're going to do is to create a new variable called data problem template, and that is going to be equal to prompt template. What we need to do is to define the input variable and also the template. In this case, the input variable is going to be the business problem, and then our template is going to be convert this business problem into a data science problem, and we're going to pass the business problem. So let's write that down. Okay, so we have a prompt template with the input variable, and the template convert the following business problem into a data science problem, and we pass the business problem. So now that we have a prompt template, in order to use it effectively, we need to use an LLM chain. So we're going to create a data problem chain, and we're going to set it equal to LLM chain. We need to pass our LLM through the LLM chain. So we're going to use the LLM that we used in the previous video. We're going to set LLM to that LLM. And then we're going to set our prompt to be our data problem template that we just created. And instead of using the LLM directly, what we're going to use is the run method on our data problem chain based on that prompt. And we are also going to set variables to truths in order to see the thought process if we want to look at that. So let's write that down. So after our prompt template, we're going to write data problem chain, and then we're going to set this to LLM chain. We're going to set our LLM equal to our LLM, and then our prompt is going to be the data problem template. That is it. And then variables is going to be equal to true. Excellent. And then we also need to change this bit here. So now instead of using the LLM directly, we are going to use our chain. So data problem chain, in this case, .run. And also we need to say that the business problem, this is the notation, our business problem is going to be our prompt. Let's run now and see what happens. I'm just gonna copy this last bit. So now I show you, oh, I missed the 5, but we can rewrite that. That is no problem. So let's rerun. Okay, so now instead of saying convert this into a data science problem, we're just gonna add our business problem and it will output the data science problem. So we write that down. I would like to know what the volume of the Twitter stock market is going to be the 1st of January of 2025. We press enter. And boom, data science problem, predict the volume of the Twitter stock market on January 1st, 2025. Okay, so for now, we've only generated the data science problem, but we're also interested to know suitable machine learning algorithms that will be able to solve this problem. So currently we're using just a single chain, and what we can do is to chain several of these chains together sequentially to bring them together to perform multiple tasks. So we're going to create another prompt template and another chain. Let's go with the prompt template. So we're going to copy and paste, and then we will modify our first template. So the second prompt template is going to be called model selection template, and now our input variable is not going to be business problem, it's going to be actually our data science problem. I'm going to call it data problem, and then our template now is going to be give a list of machine learning algorithms that are suitable to solve this problem. And then we're going to pass the data problem. So now it's going to be a model selection template. Okay, model selection template. Cool. The input variable is going to be now data problem. And now this is going to be to give me a list of suitable machine learning algorithms to solve this problem. So give a list. And then this is not business problem, this is data problem. And now we're going to add another chain. Let's copy our data problem chain, and we're going to modify that to create a model selection chain. So, model selection underscore chain, right? LM, the same LM, but now our prompt is not our data problem template, is our model selection template. like that. And then verbose to true. So now what we need is a way to link this change together, because now they're just working independently. And here's where we're going to use the simple sequential chain. So we're going to create an instance of our sequential chain, and we're going to set that to simple sequential chain. So there's one positional argument that we need to set for our simple sequential chain, and that is the chain's positional argument, which is a list of the sequential chains. And the order is super important here. So the first chain that we're going to run is the data problem chain that generates our data science problem, and then we run the next chain. So the output of this chain, the data problem chain, will then get passed to the model selection chain. So after model selection chain, we are going to write sequential chain, and that's going to be equal to the simple sequential chain. Okay. Another thing that we need to do is to change the response. So now we are no longer using the data problem chain, we are using our sequential chain. So let's just write that down, sequential chain dot run, and then we're just gonna pass, and this is just how the syntax is. No, it will throw an error. We're gonna pass the prompt like this. So let's run and let's see what happens. We have a little error. So here in the input variables, there was a comma. Great. So as you can see, we have an output, which is a list of machine learning algorithms. The simple sequential chain is only outputting one output, which is the list of machine learning algorithms, and it is not actually outputting the data science problem. And this limitation arises because a simple sequential chain manages only one single output and one single input. So in order to fix this, what we're going to do is to use a sequential chain instead of a simple sequential chain. What we need to do is to swap here the simple sequential chain for the sequential chain. But sequential chains are a little bit more complex than simple sequential chains, so there are other things that we also need to change. So first of all, we need to specify the output keys. So the output key for a data problem chain is going to be the data problem. And we also need to update our model selection chain. So the output key is going to be the model selection. And then we need to replace our simple sequential chain with a sequential chain and specify that our input variables for the sequential chain will be purely the business problem, and the output variables will include multiple output variables, the data problem and the model selection. When using a sequential chain, we need to pass through a dictionary, so something to take into account. So our dictionary is going to take the business problem as a key, as well as our prompt. To get our data problem and the model selection, we can access them separately from our response. So let's change all these things. So first of all, what we need to do is to add output keys here in the chains. Let's do that. So for this first chain is going to be the data problem. For the second chain is going to be the model selection. Okay, and then for the next chain is going to be both the data problem and the model selection. So now this is no longer a simple sequential chain, this is a sequential chain. Right, and then the response is going to be the sequential chain, and now this works like this. We remove run and then say that the business problem is going to be the prompt. And now we're going to write, so we're going to access the data science problem and the model selection from our response. Right, let's run. Okay, another mistake, no problem. So let's check what this is. So an input variables. Oh, right. So what has happened here is that I've missed the input variables for the sequential chain. So we also need to specify that. Let's write that down. So that is going to be the business problem. Okay, let's see if this is happy now. Great, so now we have two outputs, the data science problem and also the list of suitable machine learning algorithms. What we're going to do in this video is to import the Wikipedia API wrapper tool, which allows us to make API calls to the Wikipedia API. Why is this useful? So, well, it turns out that the model that we are using, which is the GPT 3.5 Turbo, is trained up to September 2021. So if there are new algorithms released after that date, the LLM itself won't be able to access that information. So this API wrapper allows us to access information that is released after September 2021. So if there's any relevant, suitable algorithm that has been released after that day, or app will have access to that information and also other information that might not have been considered by our LLM. Okay, so the first thing that we need to do is to update our prompt template to include this Wikipedia research. So the template that we're going to use for the last prompt template is not going to just take into account the business problem, but also the Wikipedia research. So what we need to do is just to add while using this Wikipedia research and pass the Wikipedia research. We also need to create a Wikipedia API wrapper instance, and because we are creating a lot of things already, we're going to start building our functions, and the same way that we did last time, we're going to start to cache the functions as well. So let's start doing that. So let's go back to the section in where we were caching the functions. So we're gonna use st.cache and then resource. We'll get that explained in a second. And we're gonna define a function that is gonna be called wiki. We're gonna pass our prompt, and what we're gonna do is to create a variable that is gonna be called Wikipedia research, and what we're gonna do is to set this equal to our Wikipedia API wrapper, and we're gonna run our prompt. And then this is gonna return the wiki research. Cool. Then what we're gonna do is to write a function for the prompt templates. And what we're gonna do is to move this thing. We're gonna move it up there. Wait. And this is going to return our data problem template and our model selection template, and then indentation, please. But not just that, what we need is to add to this template, as I said before, while using this Wikipedia research. And then this is going to be right. Next thing that we're going to do is to create a function for our chains. So let's do that. So let's move our chains, all of them. Gonna move this here. Let's tidy things up. So things that we need to modify from here. So now our data problem template and our model selection template is actually the output of this function here, which is the prompt template. Prompt templates. So what we're going to do is to change those things here. So one is the first output of the function, and the second is the second output of the function. So this is no longer going to be this, but it's going to be prompt templates, the first output, and then the second is going to be the second output. What is going to return is our sequential chain. And now I'm going to create a function that is going to take the prompt and the Wikipedia research, and it's going to use the chains to create the outputs. So it's going to be called chains output. Let's do that. Right, so we have loaded the function chains, and then we have passed or as a dictionary or prompt and or wiki research. And then what we have done is to extract from that our data problem and the model selection, and then the function returns both the data problem and the model selection. Cool. So that being done, we also need to tidy up the prompt part of our code. So let's go there. So this is how it looks like for now. So this is no longer going to be at your prompt here. It's going to be what is the business problem you would like to solve. Okay, and we're gonna change this to text area because this will allow more room for the user to write their business problem. And also we need to tidy up the if prompt statement. So now what we're gonna do is to set the wiki research is gonna call this a function, and we're gonna pass the prompt. And now what we want is to use the function chains output to output the data problem and the model selection. And we're gonna pass both the prompt and the Wikipedia research. So we no longer need the response. What we need to do right now is my data problem and my model selection. So let's rerun. Okay, so we can see now the text area here. So we're gonna write the same business problem as before. So I would like to know what the volume of the Twitter stock market is going to be the 1st of January 2025. Oh, I've written something wrong. Absolutely no problem. Where is that? Cool. So now we get the data science problem and a more curated list of machine learning algorithms. So we have used cache resource decorator before or wiki function instead of cache data. It turns out the cache data is assigned to cache functions that return data, whereas the cache resource is assigned to cache global resource. In this case, it just works better to use cache resource for a wiki function, but you can go to the Streamlit documentation to read a little bit more about it if you're interested. So now that we have our list of suitable machine learning algorithms, it would be great if the user could select their choice of algorithm to do their predictions. So in order to enhance user experience, we're going to implement a selection box with Streamlit. But for that, we need to format first our list of machine learning algorithms into a tuple or into a list. So what we're going to do is to convert our list of outputted machine learning algorithms into a tuple that we can pass to our selection box in Streamlit. So let's do that. So this function, what it's going to do is to get the list and assume that each line corresponds to an element of the tuple. It's going to remove the enumeration and also is going to convert each element to string. And what it's going to do as well is to add a new element that is going to be select machine learning algorithm, and that is going to be at the start of the tuple. So let's write that down. So now that we have this function, we can use it to format our list of algorithms and pass it as the options for the select box. So let's do that. So here, after writing the model selection, formatted list is going to be the list to select box. We're going to pass our model selection, so that will transform it. What's going on? Okay. And then selected algorithm is going to be equal to this select box. So st.select box, and we're gonna say select machine learning algorithm. Okay, and then we're gonna pass the formatted list. Let's see what happens when we run. Great, so here we have our selection box. We click and then we can select whichever algorithm we want. But now, obviously, if we click, nothing happens because we haven't linked this to anything else. But we're going to do that right now. In order to solve our data science problem with our chosen machine learning algorithm, we're going to use the Python agent. The Python agent is going to be equipped with a tool, which is the Python REPL tool. So in order to do that, we're going to create a function that initializes and configures this Python agent. You can go to the documentation to get a little bit more into the details of this Python agent. So the great thing about this agent is that not only is able to write Python scripts, but also is able to execute it. So now that we have initialized our Python agent, we can use it to provide a solution to our problem using the algorithm chosen by the user. So in order to do that, we're going to use the .run method on our Python agent and request a generation of a Python script to address our data problem and also to solve this problem as well. So in order to do that, we're going to create another function that is going to be called Python solution. So what we're gonna pass through the run is write a Python script to solve this, and then we pass the data problem that we have generated from the chain. Using this algorithm, we're gonna pass the selected algorithm and using this data set. So remember that the user CSV is the CSV file that we loaded at the beginning from the previous video. If you haven't watched part 1, I would definitely recommend that. Go watch part 1 in where we explain how to load the CSV files. So we're gonna pass that as well. Let's write all that down, and also the Python solution then would definitely need to take all of this. So we need to pass my data problem, the selected algorithm, and also the user CSV. Let's do that. So my data problem, selected algo. Okay, and then this is going to be right. So in order to integrate this function into our workflow, we are going to write a couple more lines of code here. So again, in order to make sure that things run in order, we need to say, okay, if the selected algorithm is not known or is different, that select algorithm, that's how we call it, right? So so the first one is select algorithm. Okay, so if it's different than that, then we're gonna add a subheader that is gonna be solution, and then we're actually gonna run the function Python solution, and then we will write down the solution. Okay, and then st.write solution. Okay, and let's not forget to write the if statement here. Right, so we choose linear regression. And we get a solution. How great is that? So if we have a look to the terminal, we can actually see the train of thought of our agent. So it's important the data set, converting the date column to date time, and then use a linear regression to predict the volume, is reading the CSV file, splitting the data set into train and test data, is important linear model from scikit-learn, fitting the model, and then doing all the necessary adjustments to the data to make sure that everything is in the correct format in order to predict the output, and it now knows what the final answer is, and it gives the final answer. Let's try now decision trees. So the predicted volume of the Twitter stock market on January 1st, 2025 is this value. Okay, last thing that we need to do really quick to further enhance our user experience, we're gonna add a couple more expanders the same way that we did in the first video. I won't go into detail because we already covered this on part 1. If you need a little refresher, come back to part 1 and you can have a look on how to build your expanders using the LLMs as well. So what I'm gonna do is to write an expander here, after what are the steps of the EDA, is going to be about the importance of reframing a business problem into a data science problem that will appear when this section is run in the application. And then I'm going to add another box about the importance of selecting different machine learning algorithms to get the best results. So I'm going to do that. So what I'm going to do is add 2 different functions for the generation of the information of the LLM for these 2 separate expanders, and then I will add with a sidebar with expander, and then include the function for the generation of the information. Let's do that. So we go to functions sidebar. I'm going to add that there. So we have the first one, write a couple of paragraphs about the importance of framing a data science problem appropriately, and then the second one, write a couple of paragraphs about the importance of considering more than one algorithm when trying to solve a data science problem. And then we will add the sidebars within the flow of our main script. So the first one is going to go here before the prompt. And the second one is going to be after the model selection. Right, so I have rerun everything since the beginning so you can see. So now this appears here, and we have the importance of framing a data science problem appropriately. We're gonna write the business problem again. And then when we run this, let's just check that this appears there. Is one algorithm enough? And then this is generated there. And that concludes the second video of the series, but the fun doesn't end here. As you continue your data science journey, consider experimenting with the selection of different algorithms. If you want to go a step further, you can use your agent to output evaluation metrics or use the generated code for manual execution. Exploring diverse machine learning algorithms and comparing various evaluation metrics is crucial in order to get the best results. In the upcoming video, we'll wrap up the development of our assistant. We'll look into the concepts of memory and indexes, and we will further enhance the user experience of our app. Memory will empower our model to retain past interactions with the user, while indexes will organize documents for app utilization. Be sure to download the completed project and sample data from the DigiLab Academy website. There, you'll also discover additional resources and courses on data science and AI. The written tutorial is also linked in the description. If you like this video, don't forget to like and subscribe to be updated with our latest tutorials and upcoming content. Thank you so much for joining me in this journey, and I can wait to see you in the next part.